In this unit, we're going to talk about queries and geoprocessing. Queries are questions that we ask of the data. As we looked at previously, we could see data superimposed on other feature classes or themes or shapefiles that have geographic relationships to each other. So one type of query might be find all crimes that occurred within 1 mile of a school. Other queries that we can ask may be of the aspatial data, the tabular data, or the attribute data, where I want to find all crimes that occur on a Friday. And then I think most importantly, we can combine these. So we can find all crimes that occurred within a mile of a school that occurred on a weekend. And so those combine the spatial and the aspatial data. This lecture will talk about all all the things and the components of these types of data that you've probably heard of in other classes as well. So data types used in GIS data fields. Now fields are going to be attributes. So something like POP 2003, day of the week, crime type. Those are called fields, while the elements that read across are called records. So if there are 43 arsons in a particular year, it has 43 records. And then the fields such as date that occurred, time that it occurred, beat, or whatever else that read down are called our fields or attributes that are used to describe them. Now, there are different data types that we can have. Things like character strings. It might be an address or the word homicide or a drop-down list that we can utilize. There might be integers like 4,387, -92, 307,000. So looking at double precision or floating points. So numbers that have decimal points. So integers do not have decimal points. Floating points do have decimal points. Or something like dates. So when we look at data, what are we looking at right here? When we look at an attribute table, what are we looking at? So for something like simple assault, that might be a character string. When we look at report date, that's obviously going to be a date. When we look at premise, that's going to also be a character string. And then we look at our X and Y, and these represent northings and eastings. These are going to represent probably integers in this case. A lot of times when we work with crime data, there's going to be a lot more character data as opposed to numerical data. When we work with census data, where we look at POP 2013 or average family size, we're going to be working a lot more with numbers, whether they're going to be stored as decimals like average family size or POP 2013 or POP 2020, which are going to be stored as what we call long integers as opposed to short integers. And then we can see some other things here, like I alluded to before, where we look at this is census data. So we can see this FIPS code right here, which is represented as a character string, but we have some integers, we have some floating points right here. So you can see census data, when we start to combine these with some of the socioeconomic data tied in with the crime data, we can see our need for truly quantitative data here. And then you can see some of the rates. This is some of the crime rates that were created. Excuse me, where we have some numbers that are negative, some numbers that are positive, and we'll talk about some of the nature of those as well. So data can be viewed nominal data, like a town name. Basically, it's data that has no mathematical properties. I can't add my last name and your last name and get something useful out of it. I can't subtract our 820 numbers and get anything useful out of it. Or like a census tract number, even though some of these are assigned numbers, they have no mathematical properties. They're used merely to identify. On the other hand, we have categorical data. So something like crime type or weapon or status, open or closed. It could be one of two different values. We have ordinal data, and that might be categorical data as well, but day of the week, where it gets a number like 1, 2, 3, 4, 5, 6, 7, or severity. And then we have numbers like interval data, which is change in crime rate that we showed before. These are numbers that could go below 0, Where that ratio data are things like population and crime rate that cannot go below 0. I can't have a -5 crime rate. The change from 2019 to 2020, which is stored in an entirely different attribute, could be negative, meaning it's gone down, but the actual rate can't go down. Because when we calculate crime rate, it's the number of crimes divided by population. We can't have a negative number of crimes. So like we kind of addressed before, because these attributes have units, like population, feet above sea level, the year established. I just can't add those up and make some sense out of those. The key element of GIS is the ability to analyze spatial data, but we typically marry it with some of this aspatial analysis with an end goal of map production. And these days, we facilitate data-driven decision-making where that maps are just one of the products that we have as a result of GIS analysis. When we query data, we have different examples of querying data that I alluded to before, where we ask questions about the attributes. And so we can develop a query builder, and they're going to be slightly different with our ArcGIS Pro software versus our ArcGIS Online. And in this case, I would strongly suggest getting familiar with the ArcGIS Pro, because the ArcGIS Online is convoluted. It computes it all in the cloud, which is difficult to do, even some very simple calculations. We have spatial data, which is where something is. It's attached to location, distances, areas, perimeters. It's usually presented in map form. I want to find all of the crimes that occurred in NCCU census tract or within a certain distance of the NCCU campus. And so census data can have various types of data. It can include interval, ratio, nominal data, so we can see state names. We have things here called FIPS. This stands for Federal Information Processing Standard, which is basically a way that we can identify counties. So if I see Madison County, Tennessee, it's 47113, where that there are no other counties, even though they might be Madison County, there might be other Madison counties out there, but none of them is going to be named 47113, which is a combination of the state and the county. So in Durham, we're 37063. Over in Guilford County, they're 37081. There's no other 37063s. There's no other 37081s. You also notice when we look at the attributes, these are going to be left justified as opposed to right justified. Numbers are right justified. They start at the right and go to the left, where that left justified starts at the left and goes to the right. And another key that tells you these are stored as text, where that this has a little 0 right there. In reality, if we were storing numbers, there is a 0 here or a 0 here or a 0 here on these numbers, but it's implied. I think my kids used to call these ghost numbers back in the day. And we've got examples here, like of your social security number, where that if it starts with a 0, we just don't delete it. So when we select data within tables, it's fairly easy to do. So literally, if I open up the table, I can just literally click on the tab right here in the attribute table. So if it's highlighted in the map, it's highlighted on the table, or I can grab these in the table, and I'll do an example of that when I open up the database. And so we can see the one-to-one relationship between the attribute table and the number of elements. And in this case, these are called features within the particular feature class that are selected. But you can see that there are 10 records selected, and then we can see the nice organization with the attributes. I can do something called a switch, so that just switches them all, so it picks out the other 90. And so you can see up at the top of our attributes, we've got increasing functionality where that I can copy these to something like SPSS or Excel. I can delete these, which you don't want to do. You don't want to go start editing data. Or we can select by attributes or zoom to these particular features if we're looking for particular crimes. Because we can perform relational operators on these, which are greater than, less than, equal to, especially when we work with quantitative data. We can also combine these with some of our Boolean operations, which are things like AND. It satisfies all criteria versus OR, which only satisfies one criteria. And then we can do things like NOT or exclusive OR, which means we can only pick one or the other. We can't pick both. We've seen these before, like our number line, where I can find something where that it's x is greater than 1. x is less than 4 and x is greater than -3. So you can see the open circle here, which means 1 won't work, but 1.01, 1.001 will work to the right here. And so I can run these queries here, as opposed to running things like logical errors where I say x is greater than x is less than 3 and greater than or equal to -3, and it includes everything, because when I use the word or, it implies either one of those. Can I think of any number out there that will either be less than 3 or greater than or equal to -3, no matter what? 87, way over here, satisfies the criteria for being greater than or equal to -3. And so when we start to run these query generators, we run into these what we call these logical errors as opposed to syntax errors. We see one here that says x is greater than 2 and x is less than or equal to -1. I can't think of any number which satisfies both of these criteria at the same time. So when we look at something like this, and we'll run some really simple queries, is that in ArcGIS Pro, we have a field. So what field are we looking at? The operator, and the value. So I might say crime type equals homicide, and it'll give me just all the homicides from all 30,000 crimes that we have. What it does in the background, it generates what we call an SQL statement. It stands for Structured Query Language. And our previous iterations of our ArcMap software made you generate these statements as opposed to these statements, where it lets you just go and pick out the fields and it'll generate the SQL in the background. So when you interact with databases, you're typically running this language here, but what we've done here, we've made it really easy in that we can go to fields, operators, and values. That'll generate it for us. And so what we can also do is add to the selection, remove, or select subset from current selection, so that I've gone through the trouble of picking all crimes within a mile of a school, and then from there, I want to select a subset from the current selection, which just gives me those crimes that occurred on a Friday. We can also do a spatial query, so I can do things like new selections. Okay, so I can look at where's the rate greater than 30, and then you can see the accompanying SQL selection that I don't need to worry about unless I want to do something really, really fancy that I can't do within this little GUI right here. So a spatial query using SQL, I can also start to combine these, where I say, all right, the rate is greater than 10 and the rate is less than 30. And so that'll give me everything where the rate is between 10 and 30. So I can start to combine these ands and these ors to just look for kind of basically limits here. This is what it looks like here in SQL. So the rate 2021 is greater than 10 and the rate 2021 is less than 30. And you can see the new selection that I've created where it highlights 37 out of the 100 block groups that satisfy that particular query. So something that has a rate of 5 won't be selected. Something that has a rate of 35 will not be selected. We can also generate queries that tell the difference between strings and numbers, where that I have a region here called subregion, and it says contains the text south. So it doesn't have anything here that says greater than or less than or equal to, because it knows that subregion, this field called subregion, which is right here, is text. It's nominal or categorical, and so it knows that it's not going to have numbers that are going to be greater than or less than to equal to each other. So we can also query strings, because strings can't be compared to one another. I can't say one string is greater than another string. I can say values are, but I can use the like command, and like I alluded to before, it contains the text. So we can look for certain things that contain the text. And so I can look for everything here that has the word assault. I see aggravated assault, simple aggravated assault with sexual motive, simple assault, all other, simple assault. So I've got all these different types of assault here. I generated this using something called a summarize, which we'll talk about probably later with tables. Now I can run this, but I can also run something that says contains the text. So previously iterations of ArcGIS Pro, I would have to generate a SQL statement. Now I can just say Give me everything where the charge description contains the word assault, or drugs, or homicide, or whatever we want to look at. And this is just what it looks like in the SQL, so you can see what it looks like. You notice it's got little quotes here because we're talking about string data as opposed to numerical data. But for the most part, we're going to be working in this space right here. We can do compound queries, and like I said before, I can select from current selection. So it treats things as an AND. This is where we run into a lot of logical errors, largely because if you have nothing selected and you want to select from the current selection, you're selecting stuff from nothing and it's going to be nothing. We can add to current selection, so it'll add features that satisfy query to current selection, or it'll create a new selection. So make sure you differentiate between these. And so you can see here I've selected a subset from the current selection, and so there's only 61 of these right here. It's hard to guess that there's 61 crimes that occurred on Thursday from 2,260 because they satisfied some other query, whether it was distance from a school or whatever we're looking at here. We can also do spatial data queries. So spatial data query is the process of retrieving data from a map theme by working with map features. So they've got real-world locations attached to them. And these are things that you cannot do through attribute query. If you were to look at the crimes, it's got the real-world locations, it's got them on a map, but it doesn't say distance from a school or distance from a highway. And so we look at this relationship between two different feature classes. We can select these by hand if we really wanted to, by using our cursor or using a table that we alluded to before. But most of the time what we'll do is look at some sort of spatial relationship, whether it's containment or intersection or proximity. And so now we can highlight these schools right here. We can open these up and we can use the control to just highlight all these schools where they're going to be highlighted on the map if we're only picking out particular schools. Once again, I've kind of shown this. We can select these by cursor. So I can just select by rectangle, and I'll show an example of this. We use it with a line or a circle or a box or a polygon. And so I just move my cursor and highlight it, and these will be selected as well. More importantly, I want to look at spatial relationships. I want to find all tornadoes within the state, all zip codes in the county, all tornadoes within 20 miles of Durham County, because we want to make sure they have logical spatial relationships with each other. Crimes typically don't intersect with each other, have the exact XY location. So if I look for all crimes that intersect with all crimes, that's going to be difficult to do. Or if schools and crimes are represented at both as points, that's going to be really hard to do. Where schools and crimes, we want to look for those within a certain distance of a school. And so some of the spatial relationships we see here are, these are all tornadoes located within the border of the state of North Carolina. Now look at a couple of these right here. You notice these weren't selected. Why? Because if we were to zoom in really fine, you notice it would be right outside the border. These might have been water spouts or something like that. We can look at all zip codes that intersect with Durham County. So look at all zip codes. So you can see this zip code kind of goes out, goes in, but zip intersects with it. And here's an example where we can look at all tornadoes within 20 miles of Durham County. And so they make a nice circle around it, so you can see these dots that aren't selected happen to be outside of 20. It could be just 20.1 miles, but they're still outside. The different selection methods that we have include intersect, contains, are completely within. So there's a lot of neat ways that we can look at these spatial relationships, because you can see here we have all zip codes that intersect with Durham County, but now we have just all zip codes entirely within Durham County. So hopefully everyone kind of notices and understands the difference between these. We can find all particular crimes that fall within a census tract. And so this is the census tract in which NCCU is located. So I want to find all incidents that intersect with the census tract. And you can see I went through the trouble of picking out the census tract in which NCCU is located. So it'll only select those there and instead of selecting every crime that intersects with every census tract, because the computer's smart enough to know that you don't want to do that, because you're going to select all of those. And so you can see there's 226 records just for the census tract within the NCCU campus or whatever we're looking at here. Or looks like a block group. So we have the input layer, the relationship, and the selecting layer. So we can see the relationship between these. We can look at proximity. So we can query all crimes within a certain distance of a school. Find all crimes within half mile of a school in Durham City. So how many of these are drug crimes? So now these are all crimes within half mile of a school. And then from those, I can say select subset from current selection, meaning just from these, we're going to pick out the offense contains the word drug. And so we can see of the 35,000 incidents in 2022, only 1,000 of those are drug crimes within a distance of a school. So we see some crimes over here. Some of these may be drug crimes, but they're not within a mile of a school. We can see crimes that are close, that are highlighted near schools. They are not drug crimes. Some of the things we need to understand are the ideas of logical versus syntax errors. So syntax error means that the actual syntax is not correct. It will not run. So something like POP 2013 is greater than 1 million and less than 5 million. Well, we need to specify what's less than 5 million. In addition, if we put funny characters or characters it doesn't understand, like $ or commas, it might not understand it. But our ArcGIS Pro software, especially the desktop software, is really good at understanding, getting rid of some of these extraneous characters, while the online version, which we'll look at briefly, will not. Logical errors, like we said before, expressions that'll run but will not give you the results that we want to, where I want to find all offenses that are equal to arson and offenses equal to manslaughter and offenses equal to aggravated assault. So for one particular offense, it can't be all of these at the same time, even though we might say the word and it's not. So we can say offense equals this or this or this. And so make sure you differentiate between the two, because when you run it, it's going to say 0. We're going to put 0 as our answer, even though we know that there's some arsons out there and there's some aggravated assaults out there. So or would be really good, way to use this. In addition, like we said before, no numbers will be less than 20,000 and more than 90,000 at the same time. So make sure you have your ands and your ors correct. A couple more logical errors that we have here is that I have high schools here and then I have crimes. Make sure they do not intersect with each other, because what are the chances that a high school intersects with a crime? We want to look at a search distance, or under my relationship that I can specify here, within a distance of. So make sure we specify those. Some other logical errors were that I want to find all high schools that intersect with counties. Well, this will just return everything. So we want to specify the county. We want to go through the trouble of picking out that county that'll do that. And then just some other errors that we run into, where that the default units that we have are in decimal degrees. We don't want to work with things in decimal degrees, so we can convert this to miles. Or a lot of times people type in, since miles and meters kind of look the same, they'll make the mistake of putting in 0.25 meters instead of 0.25 miles, and that'll make a big difference. Last thing we'll mention here is that we can combine spatial and aspatial queries. So when we look at quizzes, we can describe the steps to do these, but we need to query roads and spatial queries and perform spatial queries. So like we said before, we can select features, we can export features, because one of the big things that we do work with is that we can export features. And when we look at that crime database, we're working with 25, 35,000 different crimes. I just want to work with the homicides and export those out, because it's really, really ugly and weighty to deal with all 35,000 of those crimes. We just want the ones that are important to us. Also, we have the idea of map overlay, and we'll talk about a couple of map overlay operations. Like I'll kind of keep pushing, is that it gets really, really difficult to do map overlay operations. It gets really difficult to do map overlay operations using our ArcGIS online online software as opposed to ArcGIS Pro. So I will show a little bit of it in ArcGIS Online, but I really want us to focus on the Pro. But the ability to integrate data from two sources using map overlays is really a key analysis of GIS because it addresses the relationship between the spatial features and the attributes that exist between them. So when we look at our analysis tools and when we open this up in our ArcGIS Pro software, over on the left are some examples of all the different toolboxes we have out there. We have some increasing new tools like crime analysis and safety tools that integrate existing tools with crime-specific tools, geocoding, editing tools, server tools, parcel tools. You get a job out there, just might live in one of these toolboxes right here, like parcel tools. There are people who do parcels for a living, or geostatistical analysis. So these are some of the toolboxes that we have, and we focus on the analysis tools. These are all the analysis tools that we have here. The one good thing about our software is that we can click on the tools, open them up, and it'll give us a good explanation as to what they are. And I'm just going to touch on a couple of them here. One of them is buffering from the North Carolina Sex Offender Registry, and it just looks at areas within or outside a particular zone. So this is my house here. You can see this nice circle here is a 1 mile buffer within 1 mile buffer of sex offenders within my home. And then I expand it to 5 miles, and then you can see that number is increased significantly. And so buffer zones, they could be buffered by circular zones. They're a little bit more complicated when we make buffers around lines and polygons, but buffering is much more accurate for vector-based data than raster-based data. And then this is just an example of some buffers here, where these are buffers around our Wi-Fi transmitters on the NCCU campus. So you can see in green, 0 to 100 feet, 100 to 200, and 200 to 300 here. So these are buffers, or cascading buffers that create different zones that we have right here that we can specify, or something like this, which is a little bit more simple, where we have these buffers that are around roads, and you can see everything within 100 feet of a road versus not a road. And then you can see examples with buffers here. Some other tools that we do have is something called merge. So I have all the crimes in one county, all the crimes in another county. Why don't I just merge them to have all the counties within there? And there's another number of other tools that they have there. The tutorial is really good about focusing on some of the query and geoprocessing operations. And so I would really strongly suggest kind of going through the exercise to learn more about those, where that we cover these in 2 units there, but I just wanted to touch on the major ones when it comes to crime analysis. Now, when we start looking at our exercise 2 right here, let me get everything up and going right here, sorry. When we start looking at exercise 2, once again, it's going to work the same way. So I've got this lecture that I've posted here. I've got the chapter 2 book material. These are the data that you'll be following in the directions. I've got the map that I've posted in ArcGIS Online. So it's going to look and feel a little bit like the other map before, but we'll explain it a little bit more here. And then I've also got the ArcGIS Pro application here. So you can download the map right here. Like we said before, we we probably require you doing the book tutorial first before working on the exercise 2 tutorial. This is what we call WYSIWYG, meaning you just go through, follow directions, it hits the major points. I've gone through and done this one already. It's really some really neat stuff, and it's focused on, it's going to be focused on their area of interest, where that these exercises that Dr. McGinn and I have created are focused on Durham and the Research Triangle. And so you can see this map right here in ArcGIS Pro. And we've got a map here. Now I've got public schools as dots right here, so I can check and uncheck those. I've got homicides, I've got incidents, so I've got the homicides right here, and I can change the color on these. I can change the symbology if I really wanted to. So I can just go and double click on this, I can click on this symbology tab right here, and I can maybe click on the word, murder, see if there's anything right here. Okay, there's a death, a murder. I can do that if I wanted to. I can change some of the symbology. And so you can see these chart properties will come up over to the right, depending upon how you have your software set up in ArcGIS Pro. And if I wanted to, if I click on map, this is where I have my kind. So as you can see right here, I've clicked on some of these selection elements and I have select by attributes, and this dialog pops up, and select by location. You can notice this video has changed a little bit because I was using up too much RAM and it wasn't able to show some of the functionality. So I've kind of gone back, and hopefully this will work for us here. And so what we can do is we can run some select by attributes. And these select by attributes, like we said before, we have a feature class, and then we have the selection type. So we have select subset from current selection or whatever we want to do. For now, we're just going to run an entirely new selection. And this query editor is going to give us the field, value, operator, and value. And so we can look at a number of different things right here. So we can look at something like day of the week is equal to, and then this gives us the possible days of the week for all of these crimes right here. So I'll just click on Monday, and I'll click apply. And you can see that there's 5,146 that have been processed. And if I right mouse click and open up my attribute table, you'll see what this looks like right here. 5,146 out of 35,893. And this is just an example of one of the types of attribute queries that we can run on the attribute data. And I can dock these things here as well. So it's equal to. Okay, so the day of the week is equal to Monday. As I alluded to before, this is the SQL statement that it generates. So every once in a while, if you do have some issues generating these using this GUI or this wizard right here, we can do that. So we have new selections. And so this very first input row we can have is the drop downs. Another example here is we can look at the NCCU block groups. So we have the block groups right here. We can remove this. We can find a new selection where we look at something, and we'll look at an example from the exercise where we look at the population 2013. So we have a field. You can see a number of different fields right here. This is taken from demographic data, socio-demographic data. So POP 2013, and we can say is less than 1,000. And so I can click apply. Be careful if you put a comma there or something like that, or a dollar sign, it might not understand that. But I can click apply. And so what I'm going to do is I'm going to uncheck these. And we'll click on term block groups because that's the entire set. So I'll click apply here. So you can see all of these block groups, and I'll X out of this, and we'll open up the block groups here because I exported out just one particular block group. So now we can see the 26 block groups, and this shows all, this just shows selected. So the 26 block groups that contain these. And I can remove this clause as well, because if I want to look at something like the median age, I want to find all the median age where the median age is, greater than or equal to 30, and the median age is greater than or equal to 30 and is less than or equal to 35. We can do that as well. So we can see the 40 right here, and I can look over here and reinforce this where I can see the median age 33.7, 35, 32, 35. Okay, so I did say less than or equal to, and then these are where they exist within the entire attribute table within the 100 block groups that we're looking at here. So there's a number of different queries that we can run. So I really want you to get used to running these queries as well. We can look at rates.
And so if we go a little bit further down, I've calculated some of the rates right here. So I have the number of crimes for 2019, the rate for 2019. I miswrote that. The count for 2020, the rate, the count for 2021, the rate for 2021, and the change. So some of these are going to be 0 or greater, like the number of crimes, while rates may go up or down. And so I can look at some of these over here. So I can see how many of these are negative. So something like, all right, let's look at the rates is less than 0. So we can look at places where the crime rate went down between 2019 and 2020. And you can see between pre-COVID and COVID, crime rates went down. That kind of made sense right there, right? And we can see exactly where those happened. And you can see how these are represented in the attribute table as well. So we have a lot of neat possibilities and capabilities right here with this select by attribute functionality. We can look at tons of different things. We can start to combine these, but I want to circle over here to select by location, because if we were to look at crimes or my incidents right here, and I'll right mouse click, you can look at all these incidents right here. Down here, I can see there's 35,000, just under 36,000 of these. Now, when we look at these, we don't see anything that says distance from a school. But now I want to find all these incidents that are a certain distance from a school. So my input features are incidents within a distance of 0.25 statute miles. And so I can run this right here, and I'll go open up this attribute, open up this again. If I click OK, it disappears. If I click Apply, it stays. And so we can see these circles here, and all of these points, all of these 15,000 points, represent all of the crimes or incidents within half a mile of a school. Now, one of the things that I can do here is I can run both of these at the same time, where I say, all right, let me find all of the incidents, and I'll do a select subset from current selection where the day of the week is equal to Friday. So day of the week is equal to Friday. And so from this, I'm just going to be selecting from the 15,338 that occurred within half a mile of a school. So I can start to combine my select by locations with my select by attributes using these query generators here. And I'll click Apply, and we can run those. So now we're down to about 2,349 for those. So we've got a combination of these query generators. And so hopefully we have a good idea as to how to run a number of these different queries, how some may contain different words, how many have occurred on a Friday, how we kind of build upon these as well. And so we can look at some of these within certain incidents, some of these with certain date fields, a number of different queries that we can run right here. Now I'm going to X out of this. And what I'm going to do is open up the ArcGIS Pro, ArcGIS Online version of this as well. And so I have a link to this in the modules here. And so once again, I've got my public schools that I've highlighted here. I've got my homicides. I've got my incidents. I've got my block groups. And so I can check and uncheck these as well. But I do have query generators right here, and they're going to look and feel a lot different. And once again, I'll tell people we're going to be running these in the cloud, so these are going to take up a lot of time and a lot of space and resources. So I really implore everyone to make sure you're able to do this in ArcGIS Pro, because this simulates the book. And then second of all, this is much more powerful. You're going to see how long it takes me to run some of these queries, and it takes a long time. And it uses up what we call credits or money that we spend that you're going to eventually run out of when you're logged in. So I've got a number of different options down on the right here, so it looks a little bit different. And so I've got analysis. So I've got a number of different analysis tools, and what we're going to do here we're going to look at patterns. We've got enriched locations. Okay, and what we're going to do here is we're going to click on Find Locations, Find by Attribute and Location. We're just going to run a couple of very, very simple queries. So we have criteria, so we'll build a new query. The resulting layer is going to be stored in my cloud under the username tmaroon_degs.nccu, and I can select the folder as well, but I'll just call this Tim's Query 5. Okay, so we recognize what it is. We can set up environmental settings, and I'm going to build a new query. And so what I'll do here is I'll select from the homicides, and I have a choice of doing an attribute selection or a spatial expression. I'll run the attribute selection first. And once again, it looks and feels just like what we were looking at for the generator. I've got the fields, I've got the operator, and I got a value. So I'm going to be looking at the homicides, and what I'm going to look at just day of the week is equal to Sunday. I'm going to click add, and I'm going to run this right here. Now, when I run this, it's going to take up some time, and I can click on view status. This is a very, very simple attribute, and you can see some previous ones that I ran already in support of this class. So these are being run in the cloud. We're taking up cloud resources to run these. These are going to be stored in the cloud. So they're not running on my computer. So running this query takes a little bit of time, and it takes up time and energy. And it's a little more bulkier to run. And so what you can see right here, we got Tim's query. So I'll uncheck everything, and so now we can see all the homicides that occurred on Sunday. And I've got this little button here, so I can zoom to if I wanted to, as well as I can show the properties, show the table. I can save this. I can delete this feature layer. But now we can see everything. We're at the day of the week. It's equal to Sunday, and we can see the times, the dates that this is the case number, this is the report dates that it occurred at, and all the information about these 7 that occurred on the Sunday. I've got these little dots right here, so I can sort ascending, sort descending, or whatever I wanted to do here. And so you can see the functionality that we have here in our ArcGIS Online or AGOL. We'll run another one here real quickly. So this is Tim's query. If I were to go look at my cloud, or if I were to go open up my ArcGIS Pro, you would see that it opens as well. Okay, so we're going to go back to my tools. I'm going to run another one here. I'm going to call it Tim's Query Spatial. And what we'll do here is criteria. I'll delete this criteria. We're going to build a new criteria. We're going to build a spatial expression. And cancel this one here. And so find features from homicides. We'll do a spatial expression that are within a distance of a school. And we'll type in 1 mile. Actually, how about we type in 0.5 miles. Okay. So we'll call it Tim's Query Spatial. It's going to be saved in this cloud right here. I'm going to click Run. And then I click on View Status. And I'll let that go for a second. You notice, and hopefully everyone's getting the idea of when we run these, it takes a long time to run these in the cloud. And there it is, it's complete. So there's Tim's Spatial. And so now I've got the homicides, I've got the schools, and so these are all the homicides highlighted in this blue right here within half a mile of the school. Some of the neat things that we can do eventually, if I go to arcgis.com and log in to my arcgis.com, like most of us should be able to do using your organization's URL, I've got my own special login, but when I go to content, you can see this is added to my cloud right here. Tim's Query Spatial, made on January 18th, Tim's Query 5. These are a couple other that I ran here. So these are these hosted feature layers that I've created. In addition, something really neat that we can do as well, if you're logged in using your ArcGIS Pro, and we run these, I can add these data Now, typically, I just create databases for you, and you don't have to worry about it. But we're getting to a point in time where you're going to have to create your own data. I can go to my content here and link in my portal. So instead of linking to folders or servers or databases or anything like that, I can be linked to my cloud. There's Tim's query spatial right there that I can add in my into my ArcGIS Pro and run. So I've got a lot of different capabilities right here, but I'm really integrating both of these, and these will be stored in the cloud. Now they're more difficult to access, but a little bit easier to run. Okay, a little bit easier to visualize and share, because at some point in time with this, we can either create a real-time map with the software, or eventually we're going to click on share, export these to a web maps that we can stick into different apps and change the attribution and everything else. So hopefully I did a nice summary of queries. We should have enough skills to go through and cover some of the applications in the homework as we query some of this crime data, this very robust crime data.